Okay, so go ahead and graph number 12. Okay, looking at number 12, Dante, what I've got a sine graph, so I'm going to choose that tool. And now what characteristic do I have to change on it for mine? Okay, so amplitude of 2. Okay, anything else? Nope. There you go. Oh, did I? Did I click the wrong thing? Okay, let's try it again. Clear. I did. So we got ourselves a sine, and amplitude is 2. See, check answer. There we go. All right, what's the domain of that function? Okay, domain. Kobe. Parentheses or brackets? Yep, so parenthesis, negative, infinity, comma, infinity, parenthesis. All right, what is the range of that function? Corey, the range. Yep, so the low value, and are they brackets or parentheses? Brackets. Negative 2, comma, 2, bracket. All right, next one, we got ourselves a cosine. So, Araceli, what do we have to do to this cosine on mine? Amplitude, okay. And what am I going to type in there? 2, okay. Anything else? So if it had something being added to it, like at the end it might have said like +3 or something, that would be your vertical shift. What's that negative do to it? The negative does something to that graph. It's going to flip it up or down or right and left. Yeah. I'm sorry. Pardon me? Yeah, so is that over the y-axis or the x-axis? Yep. Yep, that's it. Okay, domain on that. Let's see. Millie. Okay, brackets, parentheses. All right, and now we want to know what the range is of that. Corbin, range? Yep, bracket, parentheses. Bracket. -2, comma, 2, bracket. All right, we got ourselves a cosine. All right, so let's see, Cade, what do we have to change on it? Okay, and what are we going to change it to? Yep, 2 pi divided by, okay, anything else? Nope, save, check. All right, I'll do the domain, hasn't changed, it's always the same. Negative infinity to infinity. Okay, Emily, how about the range? Yep, -1 to 1. Bracket, -1, comma 1. Close the bracket. All right, we got ourselves a sine. Okay, Jada, what do we got to change? 6. All right, whoops. Bless you. Sine, amplitude, 6. All right, and what else? Period, and what's it going to become? 1/3 pi, pi over 3, and how did you get that? So the b value in this one is 1/6. So what happens is, when I do 2 pi and the b value is 1/6, okay, so when I divide by a fraction, I multiply by the reciprocal, so it actually becomes 12 pi. So if it was this, if it was 6x, then you would go 2 pi divided by 6. So this one actually makes the period a lot longer. Now instead of this being 2 pi, now it's 12 pi. It's way out there. Right? So here, set amplitude, period, 12 pi. And domains and all that. Let's see. right, range up there. Dante? 2, right, -6, yes. Type in PI, and it'll give you pi. All right, so now we got ourselves a sine. All right, Emily, what transformations do we got to do? Okay, amplitude 4. All right, period. Stays the same, okay. Okay, so vertical changes to 1. All right, so domain didn't change. And Emily, how about the range? Hello, I can't hear you. Yep, -3, 5. All right, now we got to match up the graphs. So we're looking for which one of these is the sine, the cosine, etc. So let's see, second. All right, there's our drawing. And let's start with the sine here. Okay, which graph up there, Takori, is our sine graph? Sine graph is C. Okay, so we got 1 going to C. All right, and then Hector, how about the cosine? Cosine is A, that's correct. Okay, so that guy gone, that guy's gone, so 2 is A. All right, next one, negative sine. Millie? Mhm. Yep, so 3 is B, so 4 is 1C, 2A, 3B, 4D. All right, now we're looking for a graph that got slid 3 pi over 2. All right, so which way is this going to be sliding, Kate? Okay, so we're looking for a sine graph that moved to the left. So here's your regular sine. So this graph has moved to the left 3 pi over 2. So, when we do our graphs, the first mark is pi over 2, then pi, then 3 pi over 2, and then negative 2 pi. Those are our 4 sections. Okay, so we're looking for a graph where it moved. That's your value of C. And that's the same as 3 pi over 2 to the left. All right, and Corbin, which one would that be? Okay, so when we look at C, where does C start? You're looking at a graph that started at 3 pi over 2 to the left. So there's 2 of them you can get rid of. That starts at 0. This one starts at 2 pi. Now it's one of these 2. Say it again. D is in door or B is in Bob? One on the right. Okay. All right. So this one here starts at negative 3 pi over 2. So does this one. But it's got to be a regular sine graph. Because sine goes up first, then down. So this one would be negative sine x plus 3 pi over 2. Because it's an upside down sign. Follow? Yeah. Okay. So for mine, it was B. Do it for yours. All right. And guys, remember, you can use Desmos. So tomorrow you'll be able to open up that graph, or your Desmos graph that's got the A's, B's, and C's on it, and use that as well if you need it. All right, Araceli, which way are we moving on this one? What's the transformation? And it's because it's pi, it's x minus pi. No, it's inside the parentheses. So anything that happens in here, it's sliding right or left. Anything that happens out here, whether it's a plus or a minus, this is sliding up or down. Okay, so if I had y equals cosine x minus pi plus something, that would be sliding up, or minus would be sliding down. So this one is a right or left slide. Which direction? Araceli? You want to say left, but it's right. This is what we call bizarro world. Yeah, do the opposite of what you see. So C is positive pi, so that's pi right. Now, if it had been a different problem, Araceli, and it looked like this, then the C value is negative pi, which would be pi left. Okay? So we're going to look for a cosine, okay, that slid pi left. So here's our normal cosine. But now it's going to start, instead of starting at 0, 1, it's going to start at negative pi. This is a tough one because there's no negative pi's on here. None of these drawings have, that's 1, 2. This is where negative pi would be. Say it again. Oh, I'm a ding dong. God bless, Krolak. Yeah, I don't know why I had negative pi in my head. All right, look for a regular cosine then, Araceli, that starts at pi. So that's a regular cosine. Does this one start at pi? A. Pardon me? You can't see it? You see it? Okay. Does this start at pi? Nope, can't be that. How about this one? Yep, this one starts at pi 1. So that's a possibility. Okay, let's go on to the next one here. How about this one? That one starts at pi negative 1. And it's, see, this starts at 0, 1, and now it's going to slide to pi 1. So this can't be a solution because it's at negative 1. Okay, now let's look at D. Where does this one start, Araceli? 2 pi what? What's the y coordinate? Yeah, 1. Right? So out of those 4, which one is it going to be? It's either D or B. I'm sorry? B. Thank you. All right, sine, negative 1 plus sine. All right, what's that going to do to the function, to Corey? The negative 1 plus sine. Yep. What's that what transformation is occurring because of that negative 1 there? Stretched vertically, stretched or squeezed horizontally? Is it sliding up, down, or is it sliding right or left? Yep. All right, so normal sine, look at the board, what's the starting point, to Corey, of normal sine? 0 what? Right, okay. Now, if this thing moves down 1, what's the new point going to be? Say it again. Yeah, if it moves down 1, what's this point going to become? Slide it down 1 place. I'm sorry, I can't hear you. what's the coordinates? -1. Okay, so this has the coordinates 0, 0. This has the coordinates pi over 2, 1. This has the coordinates pi, 0. This has the coordinates -3 pi, 3 pi over 2, -1. If I took this point right here, this blue point, and I slid it one place down, what's its new coordinates? That's at 0, 0. Now I'm moving it to here. What's its new coordinates? So -1, -1. -1, there is no, well, -1, -1 is here. -1, 0 is here. So it was right here, 0, 0, and then it moved from there to here. What's the x coordinate of that red point there? Yes, 0, -1. So that's where your new graph is going to start. It's going to have to go through that point. So you're looking for the graph that goes through 0, -1. So I know it can't be D. I know it can't be C. And I know it can't be B because it doesn't go through that point. The only point that works is that. It goes through 0, 1. It took a sine graph. All I did was take a sine graph and slide it downward from 0, 0 to 0, -1. So it's like I just grabbed that and I did that. Okay, so this one was A. All right, the graph y equals cosine x is translated pi over 2 units horizontally. The blank, it will coincide with the graph of sine x. All right, so we talked about this the other day. So here's what I mean. I'm going to do, copy this. Control. All right, so what this question's asking you is, how do you move a cosine graph to turn it into a sine graph? All right, so if I did a cosine graph here, it would look like this. Okay, here's cosine. Whoops. Right, and pi over 2, pi, 3 pi over 2, 2 pi, 1, 0, 1. Now I want to turn that into a sine graph. Okay, this is cosine. Now watch what happens. I'm going to grab it and I'm going to slide it horizontally pi over 2. So the starting point, which is at, what's this point, Corey? This point right here. Yep. Now I'm going to slide it till it's at 0 pi over 2, because it's asking me, do I slide it right or left? Okay, so let's see. I'm going to take this thing and I'm going to grab it and I'm going to slide it to the right. And now it looks like a sine graph. Okay, if I go back, it's cosine. Now I'm going to slide it to the left pi over 2. Now it's a negative sine graph. So in order to turn a cosine into sine, you have to slide it pi over 2 to the right. And now it's a sine graph. So to the right. All right, match the graph. So Araceli, what do you think? This is the midline. So remember, that's your value of D. So which one of these can we get rid of? Okay. So what does this mean to the graph? No? Okay. So this graph right here slid up 2. All right. It used to be a cosine graph. And this tells you that its new midline is at 2. The midline of A and D are at -2. The midline of this graph is not -2. So it can't be A and it can't be C because the graph slid upward 2. And the only 2 graphs that slid upward are B and C. Okay, now what does this number tell you, Araceli? Okay, so if you look at this graph, what is this amplitude right here? 2. All right, what's the amplitude on this one? 1/2. So which one's it got to be? B. Yep. Good. Nice job. All right. The function graph to the right is going to be C plus cosine, C plus sine, cosine x minus d, or sine x minus d. All right, so let's take a look at what this is. So what you have to decide is, how did this graph move? Did this graph move up or down, and is it a cosine or a sine? All right, what do you think, Hector? This is a cosine. So a normal cosine looks like this. So it went up, yeah. So which one of these functions here? Right here. Okay, so I'm going to write 2 plus cosine x. 2 plus cosine x. Or I could write cosine x plus 2. Doesn't matter. 2 plus cosine, because it said to put the 2 in the front. All right. Now the next one was shifted right and left because it's saying it's either cosine x minus d or sine x minus d. So how about this one? So ask yourself, is it a cosine or a sine? And which way where does it start? So remember, if I was drawing a cosine, it would look like, I'll do it in red. That's a regular cosine. Okay, and then a regular sine would look like this. So now you're asking yourself, which one of those graphs could I move to recreate the blue graph? So I got the green one, and here's the red one. So what does this one do, guys? Right or left? This one moves to the right. How about this one? Right? And this one is left and left. Okay? So if I take cosine and I move it to the right, pi over 4, I get the new graph. If I take sine and I move it pi over 4 to the right, I don't get the new graph. If I take sine and I move it pi over 4 to the left, I do get the new graph. So this should be either A or B. So let's see, does it say? I'm going to choose B and just see what happens on MXL. Okay, that's to the left, pi over 4. Does it say? Oh, here's why it's not that. It says where D is the least positive value. Okay, so what that means, guys, that's important here. The least positive value. Here, D is negative pi over 4. It's left. That has to be positive. So it has to be A. Now that makes sense. All right, and the last one is just graph it, and then you're going to be doing, I would imagine, domain and range. Cosine. Okay, amplitude. Okay, phase shift, since that's plus pi over 10, I'm going to go negative pi divided by 10. No vertical shift.